The Amebis stability testing and monitoring system is a flexible and compliant means of performing small-scale stability testing and the monitoring and mapping of rooms and chambers. The system can also be used to monitor the environmental storage conditions during the shipment of samples. For small-scale stability testing, a large range of environmental conditions from 0 to 60 degrees Celsius and 0 to 100% RH can be generated, controlled and accurately monitored with minimal space requirements and without the need for desiccators or environmental chambers. Stability testing is performed by the addition of the test material and humidity capsule to a test chamber. The test chamber is a plastic piece divided into 3 compartments. To the larger compartment is added the humidity capsule, used to control the humidity within the test environment. The test material is placed in either 2 of the small compartments. Sample vials can be used if only small amounts of test material are available. The sample vial contains a porous membrane in the cap to allow moisture penetration. Humidity capsules are available within the range of 0 to 100% RH at operating temperatures of 0 to 60 degrees Celsius. Each humidity capsule is labelled with the batch code, expiry date and part code. From the humidity capsule datasheet, the user can ascertain the relative humidity generated from each different type of humidity capsule operating across a temperature range. The datasheet will allow the user to choose a humidity capsule to generate the required humidity conditions at the test temperature. The sensor cap seals the test chamber and has an inbuilt Rotronic hygrometer humidity sensor and PT100 temperature sensor for the measurement of the environmental test conditions. Each sensor cap is uniquely numbered and comes with a calibration certificate. The small volume of the test environment ensures very accurate and test-specific data. To capture and store the temperature and relative humidity measurements from within the test chamber requires the connection of a logger cap. The logger cap includes a memory chip for the storage of 8,500 temperature and humidity readings and a transceiver for the wireless transmission of data. The logger cap is powered by a 9-volt battery, and this battery also powers the sensor when the logger cap is connected to the sensor cap. The logger cap is first programmed by the Amebis control software through the docking station on the base station before connection to the sensor cap. The initiated test can now be incubated at the required temperature. Test readings are taken and stored on the logger cap memory as programmed, and this ensures continuous data collection throughout the study for each test. The Amebis temperature-controlled incubator can be used to control the test temperature. These compact incubators can be stacked 3 high and have a working temperature range of 5 to 65 degrees Celsius. The temperature and relative humidity readings stored on a logger cap can be downloaded wirelessly to the Amebis controlled software via the base station. Both the base station and the logger cap contain a transceiver for wireless communication. The user can request the data via the Amebis controlled software, or the software can be programmed to download the data at set times. The data is maintained on the logger cap as a backup precaution until the test is complete. The logger cap can also continue to collect measurements once the test is removed from the incubator, resulting in the collection of data on the environmental storage conditions for the test materials right up to the time of analysis. Data can be downloaded from the logger cap wirelessly or by connection of the logger cap to the base station. Once the data is downloaded to the Amebis control software, it is processed and presented in various reporting and graphical formats. The Amebis control software is 21 CF4 Part 11 compliant and includes a networked database. The software has many features for alarming and presentation of data, and the environmental storage conditions for a test can be easily reviewed. The easy generation of a large range of environmental conditions and the accurate measurement of test-specific data makes the Amebis system ideal for performing stress testing, force degradation, polymorph and recrystallization kinetic studies. Pre-formulation and formulation development stability studies can also be performed using the Amebis system. The design of the test chamber ensures different test materials can be confined to their own enclosed test environment, resulting in improved sample integrity and less risk of cross-contamination, and is ideal for potent or toxic materials. The Amebis system can be used for the wireless mapping and monitoring of rooms or cabinets by simply replacing the test chamber with a stand. The Amebis control software can present the mapping and monitoring data in a range of reporting formats. In the context of ICH Q10, a product can truly achieve a state of continual improvement by quality access to significant real-time data as facilitated by the Amebis technology. In addition, the concepts of process analytical technologies and quality by design currently applied to pharmaceutical manufacturing could also be extended to include stability testing utilising Amebis technology. Find out more at www.amebisltd.com.